All right, so y'all, 5.1 talks about normal distributions and something called the standard normal distribution here. So, properties of a normal distribution. So, I'm going to kind of scroll down here, y'all. So, in a normal distribution, we're going to have this bell shaped curve where, let's see, the mean, median, and mode are all going to be the same. The normal bell shaped curve is symmetric about the mean. Sorry, here we go. All that means, y'all, is that this is a line that cuts the graph directly in half, okay? Let's see, the area underneath the entire curve, this area here, y'all, the blue area is going to be equal to 1, as in 100%. The normal curve approaches but never touches the x-axis. So here's my x-axis. Y'all, my graph gets really, really close to it, but never actually touches it on either side, okay? And then between mu minus sigma and mu plus sigma, the center of our curve, right in here, the graph curves downward. So we start to go like this, and the graph curves down, boom, in that area. Okay. And those are what we call our inflection points. So let me scroll down a little bit further and let's figure out what we got here. So normal distribution can have any positive average and any positive standard deviation. These two parameters are actually what shapes the distribution. The mean gives the location of the line of symmetry. So the mean, again, is just going to be this part right here. And the standard deviation, y'all, describes the spread of the data. So let's take a look here. Let's take a look at this first problem, see if we can't figure out some things for this. So it's asking us to find the normal curve with the parameters, okay? So y'all, the first thing I'm going to do, I'm going to look at each of these curves, and I'm going to see if I can find their averages. Now remember, y'all, the average is always going to be this point right here. So for this one, my mu, my average, looks like it's about 3.5. If I come to this one, my average here also about 3.5. And if I come to this one, my average here, y'all, looks like it's about 1.5. Okay. So we got a couple of our averages. Now, the second thing we're going to talk about, y'all, is our sigma or our standard deviation. Okay. So let me write this out. Standard, oops. Let's make this a little bit better. Standard deviation. Okay. The standard deviation, y'all, describes the spread. So the bigger this number, the wider my graph. Okay. So y'all, I'm gonna try to do this as simply as possible. If we looked at the graph of C, this is the one that had an average of 1.5. Look, y'all, E is one that has an average of 1.5. So I know this has to be E. So that means, my friends, that D and F are going to have to get matched with A and B. So the bigger my standard deviation, the wider my graph. Okay, so I know that D and F both have averages of 3.5. But if I look at my standard deviation here, that's 0.7. If I look at this one, this is 1.5. Since this number is bigger, this is going to be my wider graph. So this has to get matched with F, and that's going to have to get matched with D, okay? Because it's more narrow. Alrighty. Question number 2 says answer each question pertaining to the following distributions. Okay, let's do a couple of things. Let's see if we can find some averages here. So if I'm going to find the average of A, I'm just going to kind of scroll down here. That looks like it's going to be about 45. And if I look at C, hey, it's the same average. It's 45. And if I look at my mean or my average for B, it's going to be 60. Okay, so now they're asking me, which one has the bigger mean? Well, B does, right? Because 60 is bigger than 45. So we're going to say B. Okay, which one has the bigger standard deviation? What they're asking me, my friends, is which graph is wider? Oh, we'd say C does. Okay. Which two graphs or two curves have the same average or the same mean? A and C. And what is the mean for the curve B? We said that was going to be 60. Okay. Alrighty. For question 3, it's asking us here, what is the mean weight and standard deviation for all newborns in the US in a recent year? So again, y'all, first thing I'm going to do, I'm going to see if we can find our average. That looks like it's about 3,300. Okay. Now, y'all, where these points are right about here, this is where we're going to find our standard deviation. My standard deviation is just measuring the distance between those values, okay? So if we were to take, say, 3,900 minus 3,300, looks like we'd come up with about 600. So my standard deviation here, y'all, it's going to be about 600 there, okay? And I'll do the same thing for question number 4. Let's see if we can find our mean. So y'all, I'm going to go right to the top, and I'm going to kind of scroll down here. And this is about 650. So I'm going to say my mean is about 655. Okay. Now, y'all, I'm going to come over here and I'm going to kind of find these 2 points right about there. And I'm going to kind of scroll down. And again, y'all, I'm kind of guessing here, right? So I might say, look, like that might be 635. And if that's 655, my standard deviation is going to be about 20. Okay. Let me continue scrolling down. And let's see, can we find, again, same thing, can we find the mean on this curve? Okay, so let's see if we can find our average. So my average here is going to be 52. Okay, and then my sigma, let's see, my sigma, let me see if I pick these points right about here and I scroll down, that's going to be about 8. Okay, all right, same thing for the next question, y'all. Let's see if we can find our average. So it looks like my average is going to be about 15. And again, if I were to pick kind of these points right about here, y'all, and I'd kind of go down, I'd say, look, that's about 19. So my standard deviation is going to be about 4. Okay. What we're trying to do with these next couple of problems, y'all, we're just trying to figure out, is it a normal distribution? And if it is, what's the average and what's our mean? Y'all, if I look at the second graph, that is not right. Why? Because my graph is crossing the x-axis. So this is not going to be representative because it crosses an x-axis. Okay. I'm going to zoom in here, y'all, so I can get a better picture. And let me scroll down. Okay, that looks like that's going to be about 19. And then again, y'all, if I kind of pick my standard deviations right about there, looks like that distance here, y'all, is about 3. So this is 19 with a standard deviation of about 3, okay? Alrighty, I'm going to keep moving. And we're going to talk about something called the standard normal distribution. So in a standard normal distribution, y'all, my mean is always going to be 0, and my standard deviation is going to be 1. Okay, so mean of 0, standard deviation is 1 is what we call our standard normal distribution. Alrighty. As I'm doing this, y'all, what we're going to do is we're going to come back, and we talked a little bit about this at the end of chapter 2. We're going to revisit it in here in chapter 5 with the standard mean and the z-score, which is the value minus the mean divided by the standard deviation. So a couple of things about our normal distribution, okay? As we get closer to the left, y'all, the area underneath the curve is really close to 0. As we continue to move to the right, my area is getting bigger and bigger and bigger, okay? From 0 to the left, the area is 0.5 because the whole area is going to be 1. And as we continue going further, as we get closer this way, the area is going to be very close to 1. Okay, so now the next part says, can we find a cumulative area that corresponds to a z-score of a negative 1.25? Y'all, I'm going to show you 2 ways of doing this. So negative 1.25 would be somewhere right about here. Negative 1.25, negative 1. Come on. Negative 1.25, okay? We're going to find the area to the left, okay? So a couple of ways we can do this, y'all. We have a table. Let me see if I can find my table. Sorry, guys. Come back this way. Oh, maybe this is it up here now. Let's go back this way. Actually, you know what? I'll get it from here. Let's go to my stats folder. Standard normal table. Let's open this guy up. Here we go. Okay, so y'all, I'm going to use my table here, okay? Let's come back to our problem. We're looking for negative 1.25. Okay. So y'all, I'm going to zoom out just a little bit. Right here where I have my negative 1.2, the first one is negative 1.29. The second one is negative 1.28. I want to get to negative 1.25. So y'all, right here, 10.56. That's going to be my area. The area underneath the curve, 10.56. Okay. That's how we find our area using our table. Okay. Let's see. Let's find an area that corresponds to a z-score of 2.15. So look, y'all, 2.15 is going to be all the way over here. So I'm finding the area under all of this. Y'all, my area should be pretty big. Remember that the total area, y'all, is going to be 1. And we're almost all the way to the right. So we should be relatively close to 1. Let's take a look. Let me come back to my table, 2.15. So I'm going to scroll down a little bit further. Okay, here's 2.1. This is 2.10. I'm trying to get to 2.15 right about here. Check it out, y'all. 0.9798, right? Remember what we said. It's going to be pretty close to 1. Okay. Now, there's another way we can come back, y'all. There's another way we can do this using our calculator. So, y'all, I'm going to grab my calculator real quick here. Here we go. Okay, let me come back. Let me turn, it's already on. Let me clear my screen. Okay, I'm going to move this guy over just so I got some room here. So, y'all, when I'm going to find my area using my calculator, I'm going to go to second, and then I'm going to go to the button that says VARs because I want to get to my distribution, which is right above that. I'm going to go to number 2, which is my normal CDF. Okay, I'm going to hit enter. Now, y'all, on some of your screens, it might look something like this, like the lower limit. Remember what we're doing, y'all. If I'm thinking about going, I'm going to come back over here, but I'm thinking about going all the way over here, all the way over here. Look, that's -4, -5. We're going to go forever. Eventually, we're trying to approach the idea of negative infinity. How about if we say something like -5,000? Okay. Now, y'all, if your calculator already has this, that's a pretty small negative number. If it doesn't, like mine, I'm going to enter in my first number, which will be -5,000. Okay, comma. Where are we going to stop at? Oh, we're going to stop at negative 1.25. 1.25. Close that off, hit enter. And y'all, look, 10.56, which is what we got. Okay. So, y'all, if you're doing this on the calculator, you can leave that first number alone. Your second number, your upper, would be -1.25. Everything else is the same. Hit enter, and that's what you should get. Okay. Now, look, let's try this one. I'm going to do the same thing. So let me clear this out. Let's go second VARs, normal CDF, which is number 2. Okay. -5,000 because I'm going all the way to the left. Okay, comma. Y'all, I'm going to stop at 2.15. Close that off. Hit enter. 0.9842. Did I do something wrong on my table? Maybe I did. Let me come back to my table, y'all. Sorry, I think I made a mistake here. 2.15. There it is. I was looking at the wrong number. 0.9842. My bad. And we got it, right? Sorry. 9842. Okay, now let's take a look at the next one, y'all. We're going to find the area to the right of -1.05. So here we go. -1.05. But y'all, we're looking for the area to the right. Okay, I'm going to show you 2 ways to do this again. I'm going to show you one way to do it on the table, and then one using the calculator. Now, y'all, my table always gives me the area to the left. Okay, remember the total area, y'all. The total area is 1. Let's find this area first, okay? So the way we can do that, y'all, using our table, we're going to go to -1.05. Let's see if I can find it. Here we go, -1.05, -1.05, right here, 0.1469. Okay, So this area, y'all, 0.1469. Now, if I want to find, if I want to find the area to the right, I can say, what's 1 minus 0.1469? Boom. And y'all, I'm coming up with 0.8531. Okay. That's one way we can do it using our table. Now, if we're going to use our calculator, y'all, we can come back and we can do it like this. Let's get this guy going. Let me clear this out. Let's go second bars again. Okay, we're going to go to our normal CDF. Y'all, I'm actually going to start at negative 1.05. 1.05, comma. And since I'm going all the way to the right, y'all, since I'm going out all the way this way, I'm going to use 5,000 as my upper limit because I'm going all the way as we kind of approach infinity. So we're just going to use a really big number there. And 0.8531, and we got it, okay? So y'all, let's do the same thing for this next problem here to the right of 2.50. So look, y'all, that's a small area. I know that my number is probably going to be a pretty small number. Let's do the same thing we did before. So I'm just going to hit second enter. It'll type in exactly what we did before. And I'm going to come back and I'm going to edit this. We don't need the negative. We need 2.50 and then enter and 0.0062. Y'all, for all these problems in 5.1, they're going to ask you to go to 4 decimal places, okay? All right. What about between negative 1.25 and 0.65? Okay. Same thing, my friends. We're just going to use our calculator, okay? So second bars, normal CDF, okay? And then, oops, sorry. Let's do that again. Second bars, normal CDF, okay. Negative 1.25 all the way to 0.65. Oops, too many numbers. Let's get rid of that guy. Okay, like this, hit enter. And y'all, 0.6365. So y'all, I'm showing you this right now. These are just going to be some basic ideas. Excuse me. Some basic ideas, just how we find the area. And then we'll start talking about like, what am I doing all this stuff for? What's the purpose of finding all this stuff? Okay. So again, here, y'all, look, negative 1.5, positive 1.5. Let's do this. Let's go second enter. Keep it simple. Come back here. You can go 50, comma, oops, 1.50. Close it off. Boom. Hit enter. And y'all, 0.8664, right? 0.8664. Okay. So y'all, let's take a look at the next problem here. It says, refer to problem 4 with the scale test scores for the New York grade English tests. What's the probability that a student chosen at random has a score of less than 640? So y'all, if you remember when we did this problem earlier today, right here, my mu was a 655, and I believe we said our sigma was something like a 20. What we're going to first do is we're going to find our z-score. Okay, y'all, the way we find a z-score is we're going to take our x value minus our average divided by sigma. Okay, so my x value in this case, y'all, is 640. We're going to say 640 minus 655 divided by 20. So let me just take my calculator here. 640 minus 655. Let's divide that by 20. Negative 0.75. Okay, 0.75. So y'all, that number would be somewhere right about here. Okay. What we're trying to do, y'all, they're asking us what's the probability that somebody is going to make less than a 640. The way we can do that is we can convert that value of 640 to a z-score, and then we can find the area underneath the curve, and that'll tell us that probability. Okay. So again, y'all, my friends, I'm going to come back second bars. Sorry. Second bars, normal CDF, negative 5,000, right? All the way to the left, comma, negative 0.75. Close that off, hit enter. And y'all, I'm coming up with 0.2266. So the probability that somebody is going to make, let me see, was it 66? Yeah, 66. So the probability somebody's going to make less than a 640, not very probable, right? 0.2266. Okay. Alrighty. Y'all, for this next one here, it says a set of credit scores are normally distributed with a mean score of 640. So let me write a couple of things down. My average is 640 and a standard deviation of 35. The credit scores of 4 individuals are selected at random are 680, 595, 540, 720. Find the z-scores that correspond and figure out if any of them are unusual. Okay, look, y'all, we're going to do this 4 times. The first time they're giving us a credit score of 680. We're going to find the z-score for that, okay? So I'm going to take 680 minus 640, and I'm going to divide it by 35, okay? 680 minus 640 divided by 35, 0.114. So my z-score, y'all, is 1.14, okay? Yeah, okay, number 2. The credit score we have, my friends, is 595, right? So look, my X now, 595. Still going to do the same thing. I'm going to find my z-score. So 595 minus 640 over 35. 595 minus 640 divided by 35, negative 1.29. Okay. Okay. Number 3. Our credit score, y'all, 540. Let's find our z-score. Okay. So 540 minus 640 over 35. 540 minus 640 divided by 35, negative 2.86. Okay. And one more, my friends. Credit score of 720. Let's find our z-score. Okay, so 720 minus 640 divided by 35, 2.29. Okay. Now, the second part of the question says, can we determine if any of them are unusual? So y'all, unusual scores are between 2 and 3 and negative 2 and negative 3. This is an unusual score, and so is that one. But it's asking us for the credit scores. What credit scores gave us those? Excuse me. We would say 540 and 720 are going to be our unusual scores, okay? And one last question here, y'all. It says that draw a normal curve with a mean of 70 and a standard deviation of 11. So remember, y'all, we want our middle number to be 70. So look, we can automatically get rid of A, okay? Standard deviation of 11. So look, y'all, here's 70 and here's 70. Well, look, standard deviation 11, y'all, that would be choice B, right? So the curve is centered at 70, and our 2 inflection points, the first one is 59, and that represents 70 minus 11, and 81, and that represents 70 plus 11, okay? And we are done.